Let us perform this definite integration, integrating from -1 to 1.1. Whenever you're given an integration like this, you should integrate from -1 to 0, and then from 0 to the positive value of 1.1. Let's see what will happen if we integrate straight from -1 to 1.1. What you will have is x cubed, not x cubed, x to the 4th divided by 4 from -1 to 1.1, and this would be 1.1 to the 4th divided by 4 minus -1 to the 4th divided by 4. 1.1 to the power of 4, let's calculate that. Waiting for a calculator. So we have 1.1 raised to the power of 4 equals, that's 1.4641, and that divided by 4 gives us 0.366. Alright, now minus -1 to the 4 is 1, so it will minus 1 divided by 4. That's what we would have. Equals, we get 0.116. So the answer is 0.116. Now let us do this. We're going to integrate from -1 to 0 of x to the 4th, no, of x cubed, I mean, dx, plus we integrate from 0 to 1.1 of x cubed. Now that will be, let's scroll up and perform the integration below here. That will be x to the 4th over 4 from -1 to 0. Let's do this part first. So this is the part that we're doing. Alright. The integral from -1 to 0 of x cubed dx is equal to, this is 0 to the 4th over 4 minus -1 to the 4th over 4. This part will be 0 minus -1 to the 4th is 4 over 4, which is a quarter. So this part would be a quarter. It's negative a quarter, but if we're going to look later on at representing an area. Here, if you integrate from 0 to 1.1 now, what you'd have is x to the 4 divided by 4 from 0 to 1.1. So you're going to have 1.1 to the power of 4 divided by 4 minus 0 to the power of 4 divided by 4. What is 1.1 to the power of 4 divided by 4? Let's go to our calculator. What we have is 1.1 raised to the power of 4 equals, and that divided by 4 gives us 0.366. Alright, 0.366. Now, a quarter is the same as -0.25. Negative a quarter is -0.25. What happened up here is that if you take both of them with the signs and just add them, you would have 0.366 minus, why did I write 0.4 up here? Should be 0.25. Alright, so now that I've corrected that, let's continue. Minus, because this would be 0.366 plus -0.25, so it's 0.366 minus 0.25 and you get 0.116. Now, that is what happened up here. But the thing is this now. These would represent areas. Let us look at the graph of this function. And we're looking from -1 to 1.1. We are looking at x raised to the power of 3. That's the curve. Let's adjust the curve a bit. I want to make it thicker so that you can see it more easily. And what we're really doing, let me zoom out a bit. We want to see the entire part of the graph that we're interested in. Okay, good. Now, let me go back to seeing my board. Then go back to the graph. Nice. Here, the integral from -1 to 1.1 would go from this point, -1, to right here would be 1.1. Right at this point. And this is -1. The areas that we really are interested in would be bounded by the line x equals -1, x equals 1.1, this part of the x-axis, and of course the curve. So if we shade the area that we're interested in, this is what we'd be looking at, all right? Now, we saw that when we did the complete integration in one go, we got 0.116. But when we did them separately, we got 0.25. So the area here, this area is 0.25. Is considered a negative because it was below the x-axis, and the other area was 0.366, 0.366. The area here was 0.366. So therefore, the total area would be equal to 0.366 plus 0.25. What's that? 6 and 5, 11. Oh, 0.366, 0.25, 6 minus 0 is 6. Oh, we're adding. 6 and 0 is 6, 6 and 5, 11. Bring down the 1, carry 1. 3 and 2, 5, 1, 1, 6. So, what we get then would be 0.616 units squared. Now, back up here, we saw 0.116, 0.116. Now that 0.116 would have been the area from 1 to 1.1, because the area from -1 to 0 is equal to the area from 0 to 1. Alright? Now, that area would be this shaded area here, because the area from -1 to 0 would be considered negative, the area from 0 to 1 would be considered positive. They would have the same magnitude and they would cancel out, leaving this extra up here. Now, that was 0.116. Now, suppose we integrate from 1 to 1.1 of x cubed dx. Would we get the same 0.116? This area here, 0.116. Let's try it out. This would be x to the 4th divided by 4 from 1 to 1.1, which would be 1.1 to the 4th divided by 4 minus 1 to the 4th divided by 4. Now 1.1 to the 4th divided by 4. 1.1 to the 4th divided by 4. We had it on our calculator, we didn't write it down here. Let's use our calculator to find that. So, we have 1.1 raised to the power of 4 equals, that would be 1.4641. Then we divide by 4 equals 0.366025. 0.366. So we have 0.366 minus, this would be a quarter, 0.25. So let's subtract 0.25 from that. Minus 0.25 equals 0.116. So we got it, 0.116. So that's what the calculation did. When you integrated straight from -1 to 1.1, the calculation saw the area from -1 to 0 as negative, then from 0 to 1.1 as positive, and the part of the area that was negative from -1 to 0 cancel out part of the area that was positive from 0 to 1, leaving the area from 1 to 1.1 as a leftover. Now, here we integrated from 1 to 1.1 and we got the same answer. Alright? So, when given an area from a negative to a positive value, to calculate using integration, then you have to go from the negative value to 1. No, I mean to 0. Do that integration and then integrate again from 0 to the positive value. That is, if part of the curve is below the x-axis and part above, or if you're not sure if part of the curve was below the x-axis and another part above the x-axis. Alright. If both parts were below or above the x-axis, then the areas would work out fine. Both of them would be positive and they add up, or both of them would be negative and they add up. There would be no cancellation. None of the area would be cut off. But once you have part below and part above the x-axis, then part of the area is going to be cut off. Alright, so that's it for this video. I'll see you in the next video.